I see that I have an alternating series here, and so I can see if these terms go to zero, and if they do by the alternating series test, this series would converge. And so let's first of all look at that. So if we looked at the limit as n goes to infinity of the natural log of k to the third over k to the fifth plus 2, well, I can see that I have an indeterminate infinity over infinity. I could use L'Hopital's rule then and have the limit as n goes to infinity. The derivative of the natural log of k to the third is going to be 1 over k to the third, but then the chain rule times the derivative of k to the third, so 3k squared. And then that's going to be over 5k to the fourth. So when we simplify that, that would just leave a k here, and then I could take this and flip it over, 1 over 5k to the fourth. And so I can see now that the numerator is 3 and the denominator is 5k to the fifth. We still have this limit out in front. And so fixed numerator, denominator becoming larger. In fact, this does go to zero. So the alternating series test says if the terms go to zero, the series converges. But now for practice, let's determine, is this conditional convergence or absolute convergence? So we are going to look at the series that has the terms the natural log of k to the third over k to the fifth plus 2. Now as I look to test the convergence of that series, I am going to, and I would actually be looking from 1 to infinity, and I'm thinking about some kind of a comparison test. But in order to decide what to compare it to, and because it's a little more complex, I'm thinking limit comparison. First of all, let's think about if I had the natural log of n and I'm comparing that to n. If maybe I'll just show you graphically. Here's our natural log graph, and then here is our graph of n, and we are looking, if we are looking from 1 to infinity, then this is always going to be greater. So our inequality is going to go like natural log of n is going to be less than n. Now I don't have n, I have k to the third, but I could replace the n with k to the third. So one thing I would know would be the natural log of k to the third is going to be less than k to the third. And the reason I would have that then is I'm trying to figure out an inequality here. If I had the natural log of k to the third, and I'm comparing it to k to the third for numerators and denominator, if I had k to the fifth, and over here I had k to the fifth plus 2, because I'm making the denominator bigger, I'm making the fraction smaller. So I can see that the inequality would go this way. And so actually I can just use a comparison test and don't have to do the limit comparison test, because I was able to come up with an inequality that goes the way I want, because this side is equal to 1 over k squared. That's just a p series where the p equals 2. So this converges, and the terms of this are always greater than the terms of the series that we're trying to test. So if one that's greater converges, then one that the terms are less than also converges. And so this converges. And so when we took the, and I didn't put absolute values on it because these were all positive from 1 to infinity, but when we do the absolute value and it converges as well, then this converges absolutely. So we have absolute convergence.